grammatical terms, it should also tell me that in some sense, it's better to describe the world using the active voice and only secondarily to describe it using passive voice. This is, by the way, a rule that if you take a writing class in any institution, they will tell you always use active voice. But nobody has explained. I mean, I so far haven't learned why. I mean, the only reason I can see is it sounds better, but that's not an explanation. That's just converting one kind of feeling into another. So, what it tells you is that these kind of rules, like always write in an active voice, always show rather than tell, these are all storytelling principles, and these storytelling principles are actually not random. They're not something that, one of those, I always had this image of some old lady with a stick in her hand who's going to beat you if you don't write that way. But actually that's not the case. I mean, that there is some cognitive explanation for why one should write that way. Right? One possibility, one is why should you write the active before the passive? Because the active is more parsimonious. Right? Because all it has, because it doesn't have the past. When you say that the cat was chased by the dog versus the dog chased the cat, I mean, the dog chased the cat while it has a construction which has a temporal component to it. It's not crucial to the construction that it happened in the past versus now. It could be chasing the cat right now, in fact, right? But it's while the cat was chased by the dog, because it is passive, so it essentially involves the past in a way that the dog chased the cat is not. So it is including one more element which you don't need necessarily in the story. So therefore, what it's saying is a principle of induction and of reasoning, which is that I should represent the world with as little coding as possible, is not a bad inferential principle in the learning of language. So something like grammatical categories, which seem to be totally unlike reasoning. Right? There doesn't seem to be a reason as to why there is active voice and passive voice. But what this shows is that actually there's an underlying it, there's a deep connection. That somehow there is a logic to how grammar and other things are put together. And that's actually a very new sort of discovery. It's only in this era of machine learning that we can start asking these questions. The reason being that there are so many rules and there are so many clauses and exceptions that to the unaided human mind, we can't really see the inferential patterns involved. It's only when you apply these more sophisticated computational techniques that it becomes more apparent that what seems like a disorganized set of rules actually has more sort of reason behind them than you think. Right? And so this combination of the fact that the mind is at a deep level rational, and that logic of how the mind works can be described using questions of computation is, in a sense, one of the great discoveries of the last 50 years. We couldn't have done it using just old-fashioned logic, because that logic doesn't tell us. It's simply too old-fashioned. Without fast computers, without access to large data sets, without access to processing power, our brains are just too weak to see the patterns in all this data. But once you crunch it through this kind of machine learning algorithms, it's clear that what seems haphazard has more reasoning to it, and what seems very, very rigid, so things should just be innate or things should just be learned, are actually far more intertwined than they were. That is to say, it's not, a linear idea of innate versus learned would be this much is innate and from then on everything else is learned. So all this is grammar, the rest is culture. Well, what's turning out to be the case is actually the two are far more closely tied to each other than you think. That at each stage, certain things are being thrown up as innate hypotheses, so to speak. And once they meet the right kind of data, your system can bootstrap a lot more than you thought it could. Right? And so the real discovery of the last 10 years in particular is sort of this bootstrapping hypothesis. Is that if you have a little bit, I mean, it's like making curd out of milk. Right? All you need is a starter. Without that, it can't be done. But nobody says that you need to have half as much curd as milk to make the rest of it into curd. You just need a little bit. Right? And so what is the minimum amount for it to curdle is the hard question. And what we are learning now more and more is, in many cases we need less than we thought we did, and in other cases we need more than we thought we did. Right? And it's in this intricacy of mapping from what can be inferred and what can be directly hypothesized and what is available in the data that all this action is happening. And the particular place where it's happening the most, best known anyway, is, broadly speaking, statistical learning techniques that come from Bayesian ideas of how the world works. So what is Bayesian reasoning? Now, traditionally, there are two kinds of statistics, and there are two kinds of ways of thinking about probability. So suppose you toss a coin, and it's a fair coin. How do you, and so a fair coin is one that gives you not 50, heads 50% of the time and tails 50% of the time. How do you get the probability of a fair coin? I mean, how do you know that for a fair coin is fair? One possibility is you keep tossing it, and you look at the frequency of heads divided by the total number of heads plus tails, and if that is 50% or it trends to 50%, you say it's fair. But that would mean, and as you know, that would lead to a very long set of trials before you are sure that, because the variation is quite a lot. Right? The deviation from the mean here is quite a lot. Broadly, the square root of the number of trials. Okay, 1 over square root. So if that was the case, and people don't take that much time to figure out that something is fair or not. So I have two conversations with somebody, with let's say a shopkeeper, and I sort of figure out that this person is cheating me. How do you do that? How do you know like that somebody is chalu? Right? You don't have that many experiences. Same thing, you could say, oh, you innately knew that this person is chalu. Well, that's a hard one to say. I mean, some people might say, oh yeah, you had, one profound kind of innateness would be, yes, because you experienced this person in a previous life. So you would need some desperate, some reincarnation theory before you could say, because I knew that he was a cheater in his last life, I also know that he's a cheater in this life. Well, that's might be true, but it seems like too heavy a hypothesis for the current purposes. Another possibility is there's something in this one interaction itself that strongly makes me think, friend or foe. And if so, how is that to be done? And the Bayesians have a very interesting way of thinking about it, which is basically saying you might have certain prior hypotheses of how a certain person is, and which we all do. We have a lot of tacit cues that we use to bias the system. So for example, if it's a shopkeeper who is trying to sell me something, and very, very subtle cues like how their eyes look or how they ask me to sit down. These are all cues that I use to set a prior probability on the ratio, the likelihood of a scam here. Right? Another prior probability generation device could be, I might have a sense for how much something costs in general. So I might know that my mother paid 50 rupees for this yesterday, so if he's charging me 75, there's no way it could have increased so much in a day. Right? So these are all sources of the prior probabilities. Those are not probabilities